In this video, we will focus on the variation of the electrical conductivity of elements across period 2 and 3. In both periods, we can see that the electrical conductivity of elements follow the same trends. They first increase from group 1 to 3 metals, then drop to 0 for non-metallic elements in group 4 to 0. In period 2, boron in group 3 is a semi-metal that cannot conduct electricity, while graphite can conduct electricity. In period 3, silicon is a semiconductor. For example, it can conduct electricity when heated. The electrical conductivity of elements is determined by the presence of delocalized electrons, as delocalized electrons help conduct electricity. When explaining the variation of electrical conductivity of elements, we have to state the type of structure and whether delocalized electrons are present in the structure. First, we see why the electrical conductivity increases from group 1 to 3. Elements from group 1 to 3 are metals with giant metallic structures. They have delocalized electrons to conduct electricity. Note that although boron is in group 3, it has a giant covalent structure with no delocalized electron. Boron cannot conduct electricity. As the number of delocalized electrons increases from group 1 to 3 metals, the electrical conductivity also increases from group 1 to 3 metals. The diagrams here show the metallic structure of group 1 to 3 metals. You can clearly see that as the group number increases, the number of delocalized electrons increases. Hence, in period 2, the electrical conductivity of beryllium is higher than that of lithium. In period 3, the electrical conductivity of aluminum is higher than that of magnesium, which is higher than that of sodium. Then, we see why the electrical conductivity drops to 0 for non-metallic elements. Group 4 elements have giant covalent structures, while group 5 to 0 elements have simple molecular structures. Delocalized electrons are not present in these structures, and so these elements cannot conduct electricity. Note that carbon has two forms, diamond and graphite. Diamond cannot conduct electricity as it has no delocalized electrons, while graphite can as it has delocalized electrons. Silicon is a semiconductor. Although it cannot conduct electricity at room conditions, it can conduct electricity under some conditions, for example, when heated. The variation of electrical conductivity of period 2 and 3 elements with brief explanation is summarized here.